Hi, my name is Talia. I'm a second year student at UCSD studying chemistry, and I'm an aspiring chemistry teacher. This YouTube channel is an extra resource for anyone who might need some help in their chemistry classes. Today's video is going to be on calculating the heat of reaction with Hess's law, which is a great combination of previous topics we've talked about as well. So I hope that if you need some help with Hess's law, you will keep on watching. And without further ado, let's get started. All right, so I'm first going to do a breakdown on what Hess's law is, and then we're going to get into some example problems and put these skills to use. So Hess's law calculates the heat of reaction using determined delta H values for each step of the reaction. And we know how to calculate delta H from the heat of formation, from the bond energy. So those methods for each step of a reaction can be used to calculate the overall delta H for the whole reaction. So the catch with this method of calculating the heat of the reaction is that sometimes your reaction steps might not be given with the proper coefficient that will lead you to get the overall reaction. Because what we want to do is combine all the steps in order to get our overall reaction. But if we need to multiply one of the reactions by 2 or 3, then that changes our delta H and therefore makes our problem a little bit harder. That will make more sense once we get into the example problems. So, like I said, we're going to add up all of the steps of the reaction, and as a result, also add up all of the delta H all of the delta H's. Now we're going to do an example. For this reaction, we are going to calculate the delta H, and we're going to classify the reaction as endothermic or exothermic. So this top reaction is what we are trying to get. Methane plus water yields carbon monoxide and 3 hydrogen gas molecules. And we have these steps of the reaction with their respective delta H values. So we want to look for what we need to multiply each of these reactions by in order to get the coefficients to properly line up and match our overall reaction. There's not a super strict method for going about this. I like to start by seeing if there's one step that has a compound in it, and that is the only instance of that compound. For example, methane is only in this bottom reaction, and I see that we have one methane in this reaction and we have one methane in the overall reaction, so my coefficient for methane is fine. I'm also going to check carbon monoxide. That's another one where it's kind of in the same situation, where the top reaction is the only reaction that has carbon monoxide in it. So it's a little bit easier. Basically, it's easier to start by manipulating the compounds where they're only in one step because you don't need to counteract any manipulations. So I'm going to see if we need to change the carbon monoxide at all. And I see that in the overall reaction, we have carbon monoxide as a product, but here we have it as a reactant, which means I need to flip my reaction. So I'm going to put parentheses around reaction number 1 and put a -1, but that means I need to do the same thing to my delta H, which means I'm going to multiply this by -1 as well. I'm going to write out my reactions down here so we can kind of see where we are. So I've written out where my reactions are with the coefficients I've already put in, and I'm kind of going to just do a little bit of an assessment. So I know that these two carbon dioxides are going to cancel each other out, and I know that these two oxygens are going to cancel each other out, or O2s are going to cancel each other out. But I still have 2 O2s here, and on our overall reaction, we don't have any O2, which means that O2 somehow needs to be canceled out. And I see that I have 1 H2 as a reactant in my second reaction and 3 H2s as a product in my original reaction. So I know that I need to do some sort of manipulation with this second reaction. And we know that we need to multiply it by -3 because we want to put the H2 on the other side and we want to put a 3 in front of it because there are no other H2s throughout the reaction that will cancel it out. And on top of that, we know that if we multiply this second reaction by -3, we're going to have 3/2 O2 on the right side as well. So that'll be 2 on the right side and 2 on the left side. And then our O2s will cancel out. So that'll solve that problem as well. So I'm going to multiply this reaction by -3, which means we're also going to multiply this delta H by -3. Okay, So now I'm going to calculate what my new delta H's are going to be. So if we multiply the first reaction by -1, that means I'm going to do this in a different color. Our new delta H is 283 kilojoules per mole. Our second one is going to be -242 times -3, so 726 kilojoules per mole. And then our third one we didn't do anything to, so I'm going to keep it as -803 kilojoules per mole. Now we want to simplify this giant set of reactions, all the steps, add them together, and see if we get our overall reaction. So I'm just going to go through and cancel out what I can cancel. Our CO2s are going to cancel out. So we have 4 halves O2 on the right side, 2 moles of O2 on the left side. So that is also going to cancel out. And then let's see what else we can cancel out. We have 3 moles of H2O on the left and 2 moles on the right. So the 2 here on the right side is going to cancel out. And we're left with just 1 on the left side. And that seems to nicely match our overall reaction. So I'm going to quickly write that down. Great. So that is our reaction. Now we need to calculate our delta H, and we're just going to add all of these up together. So 283 plus 726 plus -803 is going to be 206. I'm going to write that over here. So there are our answers. And then lastly, we need to classify the reaction as endo or exothermic. Since delta H is greater than 0, this reaction is going to be endothermic. I hope that that cleared up the concept a little bit for you. Feel free to rewind and do those problems again if it didn't make sense, or slow down the video. You can also leave any questions or concerns in the comments, and I will do my best to answer them. I hope to see you in my next video, and good luck with learning chemistry.